Hi, welcome to my channel Engineering Math Support. In this video, we are going to see about normal forms and types of normal forms. Let's move on to the video. Normal forms. A better method is to transform the statement formulas A and B to some standard forms A dash and B dash such that a simple comparison of A dash and B dash shows whether A is equivalent to B. The standard forms are called normal forms or canonical forms. Here we are going to consider two statement formulas A and B. Instead of checking whether this is equivalent to or not, we are going to convert this A into some A dash and B into some B dash. Then simple comparison of this A dash and B dash shows whether this A is equivalent to B or not. In this process, this A dash and B dash are called normal forms, or sometimes we may call it as canonical forms. This normal forms is divided into two normal forms. One is disjunctive normal form. We will simply say it as DNF. Another one is conjunctive normal form. We simply call it as CNF. To learn these two normal forms, we need two basic definitions. First definition, elementary product. A product of the variables and their negations in a formula is called an elementary product. Product means conjunction. Example, here they are given variables and their negations. I will consider any variable and some negation of the variables I will consider, and if you consider product between that, it is called elementary product. Now it is an elementary product. Product means we already know conjunction. So put conjunction symbols between variables and their negations, then the term is called elementary product. We'll see another example. I have taken some negation of the variable and the variable. In between that, if I take a product or conjunction, then this formula is called elementary product. Another example, you may take not P, P, sum, not Q. Or you can take in between that, if you take conjunction, then it is called an elementary product. The another definition, elementary sum. A sum of the variables and their negations in a formula is called an elementary sum. Here, sum means disjunction. Example, same as previous one, we are considering variables and their negations. I can take some variable and negation of it. In between that, if you take sum means disjunction. Here I am going to write the sum disjunction symbol. So then this formula is called elementary sum. Another example, we are taken some variable and negation of some variables. In between that, if you take disjunction, then it is called elementary sum. Another example, P, Q, not R. In between that, if you take disjunction, then it is called elementary sum. Based on these two definitions, we are going to define DNF and CNF. Disjunctive normal form, a formula which is equivalent to a given formula and which consists of a sum of elementary products is called a disjunctive normal form of the given formula. If you take disjunction between two elementary products, it is called disjunctive normal form. For example, I'm going to consider an elementary product. We know the definition of elementary product, variable and their negations. In between that, if you take product, it is called elementary product. So it is an elementary product, and I'm going to consider another elementary product or and not be. In between that, if you put and, it is an elementary product. So it is an elementary product, as plus this term is also an elementary product. In between the two elementary product, if you assume sum, then this form is called disjunctive normal form. The second example, you can consider any elementary product, and here this is another elementary product. In between these two elementary product, if you assume a sum, then it is called disjunctive normal form. The sum of elementary product is called disjunctive normal form. The next definition, conjunctive normal form. A formula which is equivalent to a given formula and which consists of product of elementary sum is called a conjunctive normal form of the given formula. Example, for the conjunctive normal form, we are going to consider any elementary sum. So we know the definition of elementary sum: variable and some negation of the variables. In between that, if you consider disjunction symbol, then it is called elementary sum. And we can say is also an elementary sum. In between that, if you consider a product, then it is called conjunctive normal form. Another example, R or Q or not P. This is an elementary sum. I'm going to consider one more elementary sum, and if you want, you take one more elementary sum. In between that sums, if you consider the conjunction, then it is called conjunctive normal form. To find this conjunctive normal form and disjunctive normal form, we will have a procedure. Methods to obtain conjunctive normal form and disjunctive normal form. First step, convert the biconditional and conditionals into an equivalent form which consists of negation, conjunction, disjunction only. In first step, we are going to convert biconditional symbols, conditional symbol, sometimes NAND symbol, sometimes NOR symbol, into an equivalent form. That forms must consist of only this three symbols, using the formulas what we learned in the previous lectures. Second step, if necessary, apply De Morgan's law. Third step, repeated application of distributive law until you get the conjunctive normal form or disjunctive normal form. We'll see a problems on disjunctive normal form. Obtain disjunctive normal form of the following. First one, P and if P then Q. We know that disjunctive normal form means disjunction of elementary product. Simply, if you want to remember, you can remember like this: elementary products must consist of the conjunction symbol. Here also, this elementary product must consist of the conjunction symbol. In between these two brackets, you must have the symbol or. So you remember, disjunctive normal form means you have to derive a term like this. Now you observe the given problem, P and P then Q, which is equivalent to. In the first step, we have to change this symbol into not and or symbol. To change that, we know the formula: if P then Q equivalent to not P or Q. Using that, I'm going to write the term as P and not P or Q. If you observe this term, in between the terms we will have a conjunction, and inside the term we will have the disjunction. So, but we need in between the brackets disjunction, inside the brackets we need conjunction. So therefore, it is not an disjunctive normal form. Still, we have to solve the problem. Second step, if necessary, apply De Morgan's law. Here, there is no need of applying De Morgan's law. So straight away, we will go for the third step. Third step is repeated application of distributive law. Now I'm going to consider this as your P and this as our Q. and this as our or. So then this is equivalent to P and Q, or P and R is our distributive law. So if you apply this here, we can get the next step as P and not P, or P and Q. Now, if you check the term inside the bracket, we will have conjunction. Here also inside the bracket, we will have the conjunction. In between the brackets, we will have the disjunction. So therefore, it is a elementary product, and it is also an elementary product. The sum of the elementary product is called the disjunctive normal form. Therefore, it is the required DNF. Once again, I want to clarify your definition based on this problem. A formula which is equivalent to the given formula, and which consists of sum of elementary products. Now you can easily understand the definition, I think. Second problem, find the disjunctive normal form of not of P or Q by conditional P and Q. To find the disjunctive normal form of this problem, not of P or Q by conditional P and Q, which is equivalent to, first step we have to remove this biconditional, and we are converting this biconditional into negation, conjunction, disjunction symbols. P biconditional Q equivalent to, if P then Q, and if Q then P. It is a one formula, and another formula is P biconditional Q equivalent to P and Q, or not P and not Q. Here if you observe the two formulas, in between the bracket we will have the conjunction here, and here in between the brackets we will have the disjunction here. So to solve this disjunctive normal form, we need in between the bracket disjunction. So therefore we have to select this formula to solve this problem. Using this formula, I am going to write the next step as, it is our P and it is our Q value here. If you apply this P and Q, it is not P or Q, and your Q value is P and Q. That is the first term. Or not P and not Q. Here already one not is there. Not getting cancelled. Simply will get P or Q. And if you take negation for this Q, we will get not of P and Q. Second step, if necessary, we have to apply De Morgan's law. Observe this term. Here it is necessary to apply De Morgan's law. Therefore, I am going to apply De Morgan's law, not P here and not Q, and P and Q. Or here also it is necessary to apply De Morgan's law. I can apply the De Morgan's law, P or Q and not P or not Q. Now you observe the bracket terms. In this bracket term, all the symbols are of the form and, so therefore it is an elementary product. In between these two bracket terms, we will have the sum. But if you observe this bracket term, it is not an elementary product. So therefore we have to apply the third step for this bracket term to get the elementary products. For the third step is distributive law, repeated application of distributive law. So I can write this bracket term as not P and not Q and P and Q. Since all the symbols are same, I didn't maintain the bracket, I have removed the bracket. Now if you take any two different symbols and apply your distributive law, here I will take this or and this and are the two different symbols. So I'm going to assume this as P and this as Q and this entire term as R. Therefore the first step, P and R. Here R value is not P or not Q. Maintain the bracket. Here R, Q and not P or not Q. Again, if you observe this bracket term, it is not an elementary product. Again, we have to apply the distributive law. Therefore, not P and not Q and P and Q are here. These two are the different symbols, and we can apply the distributive law. P and not P or P and not Q. Maintain the bracket here, or here also these two are the different symbols. I'm going to apply distributive law. Q and not P or Q and not Q. If you observe all the bracket terms, inside the bracket terms we will have conjunction. In between the bracket terms we will have disjunction. So therefore it is our required answer. If you want, we can simplify this term as P and not P is F, Q and not Q is F, F and F is F we can write. Or here P and not P is also F we can write, or P and not Q, or here Q and not P we can write, or not Q and not Q is F. Here we will have 1, 2, 3, 4, 5. 5 terms we got, so I have converted that into the contradiction form using the formula. So if you are having less number of terms, you no need to convert like this, just you write the term as it is. Therefore our final answer is P and not Q, or Q and not P is the required disjunctive normal form. Obtain the conjunctive normal form of the following. First problem, not of P or Q by conditional P and Q. In the previous problem, the same problem we are converted into disjunctive normal form. Here we are going to convert this into conjunctive normal form now. We know the formula, P by conditional Q equivalent to P then Q and Q then P. Conjunctive normal form means conjunction between elementary sum. I can write simply P sum. So here also elementary sum. Elementary sum means some variable, negation of the variable. In between that, if you take disjunction, that is called elementary sum. Same here also, the elementary sum will be like this, and in between these two bracket terms you will have the conjunction, then we call it as conjunctive normal form. So whenever you are solving this conjunctive normal form, we should remember this form. So we already discussed we will have two formulas. One is like this. The another formula is P and Q, or not P and not Q. Here we are discussing about conjunctive normal form. So that means conjunction between two bracket terms. If you observe these two bracket terms, in between that we will have the conjunction here. So therefore this formula we have to take, this formula we should not take, because in between these two bracket terms we will have the symbol R. So therefore we can use this formula to find our disjunctive normal form. Using this formula, I am going to extend this given problem as this is P and this is Q, that is equivalent to, we can write not of P or Q, then your Q value is P and Q, and Q, P and Q is your Q value, then our P value is not of P or Q. Next, still the first step is not yet over, because see that bracket terms you will have again the conditional symbol. The biconditional symbol we are converted into now conditional symbol. Still we have to simplify this conditional symbol into the negation and or symbols. Now I am going to apply this formula. If P then Q equivalent to not P or Q. Using this, I'm going to write the not of not will get cancelled here. So I can write P or Q. Using double negation law, we can write this as P or Q, or this is your Q value, not P or Q we are written. So maintain the bracket, and now for this we are going to apply this formula. This is your P. We are going to write not P or Q value. Not of P or Q is our Q value. Now if you see this bracket terms, there is no conditional and biconditional symbols, so we are completed our first step. Now we are going for the second step. If necessary, apply De Morgan's law. Here if you observe these two terms, the De Morgan's law is necessary, so we can apply it. So that is P or Q, or P and Q. And here if you apply the De Morgan's law, we can write not P or not Q, or here not P and not Q. Still we didn't get our conjunctive normal form. Now we are going to apply the third step. The third step is repeated application of distributive law. For applying distributive law, we need two different symbols, three different variables. So here you can consider this two are the different symbols, as well as here also we can consider these two are the different symbols, and this is your P, Q, R. Similarly, P, Q, R. If you apply this formula, we will get P, R, Q and R equivalent to P, R, Q and P, R, R. Using this formula, I'm going to write the next step as this is equivalent to, this is our P value, P, R, Q. Q value is P, and PRR. The P value is here again PRQ, or here the R value is Q. I applied that one. So this term is over. Now this and symbol, and I'm going to apply the distributive law for this. This is your P value, that is not P or not Q or not P, and not P or not Q or not Q, which is equivalent to. If you observe this bracket terms, all that symbols are same. That is in the form of elementary sum. Inside the brackets, if you check, it is a disjunction terms. All the symbols are in the form of disjunction. In between the bracket terms, we will identify the conjunction. So this is our required form. We will conclude the problem as here two p's are there. I can write only one p by using idempotent law. Here two q's are there. I can write only one q by using idempotent law. And here two not p's are there. I can write only one not p using idempotent law. Here also two not q's are there. I can write only one not q using idempotent law. Now if you observe two terms are there using idempotent law, we can write only once, and therefore I can write one P or Q and not P or not Q. So this is our required conjunctive normal form. If you observe this bracket term, it is an elementary sum. It is also an elementary sum. In between the elementary sum, there is a conjunction. So therefore, it is a required conjunctive normal form. Second problem, if P then Q and R, and if not P then not Q and not R. So using the first step, we are going to remove this conditional symbol. So to remove the conditional symbol, we are going to use the formula P then Q equivalent to not P or Q. We are going to apply not P or Q and R, the first term. And here if you apply not of not double negation law, it will become simply P or not Q and not R. Now our aim is to get this form, conjunction between elementary sum. Conjunction between elementary sum. Here there is no need of applying your De Morgan's law. Straight away we'll go for distributive law. So take two different symbols. These two are the different symbols, and here also these two are the different symbols. P R Q and R equivalent to P R Q and P R R. Using this, I'm going to write the next step as not P R Q and not P or R. The first term here, and here P or not Q and P or not R. Now if you observe, inside the bracket terms we will have R symbols, and in between the brackets we will have the and symbols. Therefore it is our required conjunctive normal form. We can write this term as not P or Q and not P or R and P or not Q and P or not R. If you check, it is an elementary sum, it is also an elementary sum, it is also an elementary sum, it is also elementary sum. In between the elementary sums, we will have the conjunction. So therefore, it is the required conjunctive normal form. I hope you can understand the concept of normal forms and its types, that is conjunctive normal form, disjunctive normal form. Kindly subscribe for more videos. Thank you.